Hi, now we will be discussing some basic but very important transformations, and we will understand these in both PySpark and SQL so that we can understand both perspective. We will start by understanding how we can get columns, then write some expressions, then add or delete columns, and then we will go through some constant values, dropping column, casting, filter, distinct, union. So there are many operations that we will go through, and then this repartition and coalesce, which is a very important feature. We will discuss this one in detail, and at the end we will also understand how we can read PySpark data frame in SQL and SQL query in a data frame in PySpark. So that conversion also we will understand. So let's get started. First of all, we will read this table sales.bakehouse.sales franchisee. We will read it using Spark, which is the Spark session .read.table, and it will create this data frame, and then we will display this data frame so that we can see the data. So here is our data frame created with these column and data types, and then here is the data which is shown using this display function. And also one feature of notebook is that whenever we have multiple cells here, and in each of the cell this heading whatever we mention, that is available as a table of content here, which can be really useful. So using this we can see what all things are there in the notebook. We can navigate also by simply clicking it here and there. So this is one of the feature which I really like. And here we have just read this table, and if we want to read the table using SQL, then what we do is we mention the query select star from the table, and star means we need to read, we want to read all the columns from this table. And here you can also notice is that we have mentioned %SQL here. So this is called as a magic command in Databricks. PySpark or like the Databricks, it by default supports 4 languages: Python, SQL, Scala and R. By default the notebook is Python here, and that's why we didn't need to mention anything here. This is the Python or PySpark code. If we want to run any other language code in the same notebook like SQL, Scala or R, so we need to mention like %SQL or Scala here, so that it knows like this code, it is different from the default language which was set above. And that's how we are able to run both SQL and PySpark code in a single notebook. So now that we know like how to read a table, next let's understand how to get columns from the data frame or the table. So if we have the data frame, then to get the list of columns, we have this .columns command. So using this, we directly get the list of the columns here. And the same thing, if we want to do it in SQL, then the command in SQL is show columns in and then the table name. So it will show us all the columns which are available in that particular table. Now let's understand how we can select some of the column instead of all the columns. So once we have a data frame, then we can select the name or country column from this data frame using this select method. So within select, whatever we mention here is comma separated, which are enclosed in double quotes, all those columns it will select and create this new data frame, and that new data frame we can display here. So this is how we can select the column in PySpark. And here we can see it has shown us those 2 columns here. And same thing if we want to do it in SQL, then the command is select. Instead of star, we will mention those 2 columns here. So name and country, these are the 2 columns we want to select from this particular table. So the same way it will provide both the name and country columns from this table. Next, let's understand what is a expression. So expression, it is a function available in this particular library which we need to import, and we can use it like this. So in our select statement, instead of the column, if we want to perform some operation, then we can use this expression using the expr keyword. In this case, I am just renaming the column. So country, it will be the column selected and it will be named as my country, as we can see here. So this is what this expr it is doing, and this is a generic function, and we can use it for anything that we want to do inside here. So let me comment this line and uncomment this one. In this case, instead of simply renaming, we are doing a concat operation. So what it will do is, it will take the city column, it will take the country column, and then append them and put a underscore also between them, and then name the output column as location. So name and location, these two columns we will get in the output. So this way, within the expression, we can mention any generic transformation that we want to do. So that's the use of expression here. And expression part, instead of mentioning expr here, we can mention it outside also. So there is another version of select which is called as select expression, and if we mention it here, then here we don't need to specify. So whatever is inside it, that will be considered as expression by default. So this is another way of using expression. And same way here, if we want to use some expression and then alias the column. So instead of putting the as column name inside expression, there is this separate function available called as alias, which is used to just give a name to any expression or any column. So this will also do the same thing. It will take city, country and give the column name as location. So it is just a different way of providing it, but we can use whichever we want. And the same thing, if we want to do it in SQL, then this is how we do it. So for concatenation or expression, we don't need to mention anything like expr or anything. Directly we can use that expression or the function that we want to use. So here also it will concate the city and country and then give the output as the name as location. So the same output we will get this way in SQL. And in the next part, let's understand how we can add a new column in the data frame. So this time, instead of select, if we mention dot with column, then what it will do is it will add a new column to the data frame. Existing column will also be retained, and then there will be a new column added as location with this expression. So this time, instead of getting only the location or the column that we specify, we will get everything, all the columns plus the location column. So that's how this location column it is added here. And if we want to add a new column in SQL, then also it is simple, like we mentioned star, which means all the columns, comma, then this expression. So this way also it will take all the columns plus this as a new column. So this way we can do the same thing in SQL. So here we get this location column, same as the previous one. And now let's understand how we can use any constant or fixed value. So let's say we have some scenario where we want to add a new column or use any value, let's say 1, 2, 3, A, B, C, whatever is. So that directly if we mention 1, it will not be able to use it in PySpark. So that's where this literal function is available. LIT means literal, and this is also available in this library. So we need to import it and then use it. In this case, what we are doing is we take the data frame, then we add a new column named as 1, and the value also it will be the numeric 1 here. That's how we will get the output here. And so whatever fixed value we need to provide, that we need to mention as a literal. So this is the way PySpark works. So here it has added this new column 1 and then the fixed 1 value that we had provided. And if we want to do the same thing in SQL, then it is simple here. Like we don't need to mention anything like literal or anything. We can directly put the value like 1, 2, 3, whatever it is, and then the alias. So this way in SQL it is easy. So this column, it is added automatically. And now let's understand how to remove some column. So from this data frame, if we want to remove the country column and keep rest of the columns, then we use this function dot drop. So it will drop the country column and keep rest of the column. So now we can see in this one like the country column is gone and all other columns are available. So this is how we can drop or remove any column that we want. And the same thing if we want to do it in SQL, then it is select star. Star means everything except country. So this except function is used to just exclude any of the columns. So this way we will not get the country column and get rest of the columns. In the next part, let's understand how we can change the data type of a column. So let's say we have some column named supplier ID, and that column by default it is some other data type, and we want to change it to double. Then this is how we do it. So we mention the call. So here you shall notice that only the directly supplier ID we can't use. We need to wrap it in a column function so that it knows it is a column, and then dot cast, so that it will cast this function into the new data type, which will be double, and that new column or the new data type, it will be available as a new column with this name like supplier ID underscore double. So now in the output data frame, we will get all the input data frame plus this new column that was here, and looks like it is saying call is not defined, and this is because like I have not imported the call function here. Let me import it. Now I have mentioned the import statement and it is working fine. So this way, like in PySpark, whatever special things we want to use, we need to import them all. And so this is the way we can cast this column. And if we check out the output, so the column we were casting is supplier ID. And if we go here, so we can see that the supplier ID column, the original column, it was big int, and now it has created a new column with the double, and here the data type is double. So this way we can cast it. So in practical, like we may want to cast any like a string column to numeric column if it is containing any numeric, or there can be any other scenario if we want to convert the data types. Then we always use this cast function. And the same thing if we want to do it in SQL, here it is like simple. So we select all the columns and then use the cast function. And in this one, like we mention like what is the column, and then is the new data type that we want to provide, and then is the alias to the column. What shall be the name of that new column? So this way we can cast the column in SQL. So in SQL it is simple, and you may notice that we did not need to import the cast function or anything. In SQL, whatever functions can be used, those are available by default. And here also we can see the same output we have got. This new column we have got it as a double column, and it has casted it from big int to double now. Next, let's understand how we can filter some of the data. So let's say if we have a data frame, and if we want to keep the rows, only the rows where the country is US, then there are two ways to do it. One way is that we use the where function, and then we mention the expression like country equal to US. So this way it will select only the rows where the country it is US, and instead of 48 rows now we have the 16 rows where the country is US. And there is another way to use it, that is using the filter function, which will also do the exact same thing. So but this time we can't mention it as an expression. This time we need to bound it with the col function here, so that it will know it is a column, and then use the equal to US. So this will also do the exact same thing. It will provide the rows where the country is US. And if we want to do the same thing in SQL, then we use this where clause. So after the table name or the query, we mention the where clause where country equals to US. So this way we can filter out any data in SQL. And one more thing to notice here is that in SQL we use a single equal to symbol, but in PySpark we have to use the double equal to, because single equal to it is used as a assignment operator which assigns a variable, but as per standard SQL this equal to is used for comparison. So the same thing we can use or filter the data using this where clause in SQL. Next, let's understand how we can distinct the data, or if we want to keep only the unique records in the output, then how do we do it? So let's say from our data frame, if we want to see how many values are there for unique country and city. So let's say in total we had 48 rows, but out of those 47 has like unique country and city. One is repeated value which it has removed. And let's say instead of two values, if we want to check how many unique countries are there, this will be obviously be less. So this way we can know that our data it has 9 unique countries. So whatever unique record or data we want, so then we use this dot distinct function after selecting the columns that we want. And if we don't select any column directly, if we mention dot distinct, then it will check all the columns to compare the distinct values. And if we find a repeated value of all the column, like this exact all these values are available somewhere else, then only it will remove that. In our case there is no such case, but it may be depending on our data. And this distinct, it can be a costly operation, so we shall use it carefully and only when it is required. And next, if we want to do the same thing in SQL, then here also we have this distinct keyword. So if we do distinct star, it will do a distinct or uniqueness based on all the columns. And if we want to get only the unique country and city combination, or let's say only country, then we mention distinct and that column or multiple column. So the same output we can get from SQL this way. Next, let's understand another powerful concept which is called as union. So what union does is, let's say if we have two data frames instead of one. So this is the data frame 1 we had originally, and this is df2, a copy of this data frame we have created, like the same reference we have stored it. And now both these data frames, if we display, so both of these, they contain the same data. The data frame df contains 48 rows and df2 also contains 48 rows. Now if we want to combine the data of both the data frame, like all the rows from df and all the rows from df2, then what we do is we use this union operation. So if we do df dot union df2, then in this df3 we will get combined rows from both df and df2. And here we can see that combined rows are 96, which we are getting. So for union we can use union, or we can also use unionAll, which both of this will do the same thing. So this also will get the 96 rows, and which is combination of both the data frames. And same thing if we want to do it in SQL, here also we have union and unionAll, but in SQL there is a difference. So let's understand that. First, let's do a union. Let's say we select star, we select the records from this table, then we select them again, and if we do a union between them, then in the union you can see instead of 96 we are getting only 48 rows. And the reason for that is union by default it will remove any duplicate record. So in our case, because the records are same, everything is duplicate, so it is keeping only one copy. But in general, let's say if we have 10 rows here, 15 rows here, so whatever are same rows, those it will capture only one. That's the functionality of union. Whereas unionAll, this will take all the rows, even if those are duplicate. So in this case we will get 96 rows. So that's where in SQL union and unionAll are little bit different. In case of PySpark, both work the same way, both provide the duplicate data. So in case of PySpark, if we want to remove the duplicate, then we shall use dot distinct separately. Whereas in SQL we have these two options, which whichever is suitable we can use that one. Next, let's understand if we want to order by some data. So let's say if we want the output records to be ordered by country column. So by order by, what we mean is this is a string column, so it will order it alphabetically. So starting with A, it will go first, and then alphabetically it will sort the records, and by default the order is ascending. So this way, this dot order by function, it is used to do order by. And if we want to change the order to descending, then we need to specify it explicitly. So we need to mention it call function here, and then the column, and then dot descending. So in general, you may notice that if we want to use dot any function on any of the column, then we have to use this call function also, like we used for alias, for dot casting, whatever operations we are doing, there we have to use this call function. That's how it works in PySpark. So using this descending function which we imported here, now it will do it in the reverse order. So now US is first, and then starting with A, Australia, it is the last. So this way we got the same thing but in reverse order. Now let's see how we can do ordering in SQL. So in SQL, the order by clause is available. Here the order and by words are separated instead of combined like it is here. And then we mention the column name. So this will also do the same thing. It will order our output by country column here. And by default, this also it is in the ascending order, as we can see. And if we want to do it in descending, then simply we specify this descending keyword, and it will do the same thing in the descending order. So this is how we can order the data based on any column. Next, let's see how we can limit some data. So let's say if we have a data frame with millions or billions of rows, and if we want to check out some sample data first before doing complete analysis or running the query on bigger data, then we may want to select or limit the number of records. And for that we use this dot limit function, and then we specify how many rows we want. So now from this df, it will take only 10 rows and store them in df2. So here we can see that the df2, it has now 10 rows. And same thing if we want to do in SQL, then at the end we need to specify limit and then how many rows we want, and it will also provide the same output as limit 10. Next comes a very powerful concept, or a transformation, which is called as repartition and coalesce. So this part, let's understand what exactly this is. So as you may know, the data frame that we create in Spark, that is created based on a big table or maybe lot of files internally. So it stores the data parallelly, it processes the data parallelly, and it create partition of the data so that it can send different partition to different executors. So every data frame, it has some number of partitions, and those partition ideally we can get using this function df.rdd. We get the rdd, and then we get the number of partitions. But as we are using the serverless compute here, which is available in the free version of Databricks, so in this cluster it is not available, but in general purpose cluster we will be able to get the number of partitions. So this way we can understand how many partitions it has created or it is planning to create based on our data. Then let's say if we want to increase or decrease the number of partitions so that we can control the parallelism of our process. So let's say if we want to do the operation with more parallelism so that it can be faster, if we have the capacity, then we will want to increase the partition. Otherwise we may want to decrease also. And that is where this repartition and coalesce comes into picture. So these both have a little bit different property. Let's understand that. So this is how both are different. So for example, in repartition, we can decrease the number of partition or we can increase also. And for any partition, it will provide its contribution or number of records to any of the output partition. So in this case, shuffling will be there. So let's say if the partitioning will happen, so some random or like maybe based on some column, records will go from any different input partition to any output partition. And similarly, if it is increasing from each of the partition, the records can go to any of the output partition. So that's how repartition works. It can increase or decrease the partition, but shuffling will be there. In case of coalesce, shuffling will not be there, and it can be used only to decrease the number of partitions. In this case, how it avoids shuffling is that it combines multiple partitions to create a consolidated partition. So that's how when we want to reduce the number of partition and just combine multiple partitions, then we shall use coalesce. And if we want to do a complete restructure or reshuffling of the partitions to increase or decrease the number of partition, then we use the repartition. But shuffling, it is a very costly operation, so we shall use it carefully and only when we want it, only when we really need it. And there is an advantage of repartition also, that after reshuffling, the output partitions will be of very similar size. But in coalesce, as it is combining different partitions, so depending on the combining input partition, the size of the output partition may vary a little, which may be a problem or may not be a problem. So these things we will have to understand the process, try out the different things, and then only we can decide. And how exactly we can specify the number of partition, that's where the repartition and coalesce command comes into picture. So this is how we specify the number of output partition. So whatever partitions are there in df, now in the output it will combine the input partitions and create two partitions, and that's how we will get the output. So in terms of the output, using display function, it will not make any difference because the output records are same only, but internally it is creating different partitions so that whenever it will need to do parallel processing, then it will be helpful. So same way, if we do repartition, then it will provide the same result, but internally it will do repartition and create two partition whenever it need to, whenever it is required. So in this one, it may seem a very simple example and maybe not much useful because it is providing the same data, but When we have a very complex process, lot of input transformation, lot of output transformation, then in between, if we do a repartition, it creates equals output partition and then process the further operation in a better way. That way it can make a big difference also. So whenever we have a long running operation, we can try out these things and see how much impact it is making. So now that we understand partitions, let's understand some more things. So let's say if we want to collect the output data into the driver, so then we use this dot collect function, and what it will do is it will provide the entire content of the data. It will provide it to the driver, and there it will be available as a array, like Python array. After collecting, it will no longer be a data frame, it will be a array in Python or a list. So it will be a Python object, and that we can manipulate however we want. So whenever programmatically, if we want to manipulate something in Python, let's say if we get a distinct value maybe for country, then we collect it, and then we can write any Python code for a for loop or anything that we want. So for those kind of operations, we use collect and then use the collected data. And next, let's see how we can use a data frame in SQL. So let's say if we are writing some code in data frame, but as you may already notice, right, SQL sometimes it is very easy as compared to Python. So on top of data frame, if we want to do any SQL operation, then what we do is we take the data frame. This limit it is option only to showcase here. I have put it. This is the main thing we need to do. So create or replace temp view, and then we give a name. So with this name, it will create a temporary view in Spark, and that temporary view, it will be available directly in SQL. So here, let's say we create this view. So it will take this data frame, take 5 rows from this, and then create this view. Now if we try to read this view in SQL, it will be accessible. So this way we can read any data frame in SQL by creating a temporary view. And let's say if we want to do vice versa, let's say if we have written some SQL query, but then if we want to do something programmatic in data frame, then what we do is we use this function spark.sql. Instead of spark.read, we used spark.sql. It will run the provided SQL query and then create a data frame, and then that data frame we can manipulate however we want. So in this case, we limit it to 2 records. So it has created this data frame which has only 2 records. So this is how we can convert a SQL query to a data frame. So now I hope overall you got some good idea how does the PySpark basic things work and what can be the use of each one of these. So in general, you may notice that PySpark, it is more of the coding approach, whereas SQL, it is more of just the user-friendly SQL queries. But whenever we want to do more things dynamically or programmatically, that's where PySpark is strong. We shall use that. But whenever there is some SQL-based business logic we want to write, that's where we shall write it in SQL. That way it will be easy. After writing in SQL, we can create a data frame, and then also we can use it as a data frame to do any programming. So that's how we can use a combination of both. And practically, I have seen that using a combination, that's what makes it more powerful, and practically also it makes it very easy and very friendly to use both sides of the ways. So that's what I wanted to share in this video. Thank you. Bye bye for now.